So our last topic for trigonometry is on radial surveys. Now, basically, radial surveys are just a scale drawing of a surface of a plane. So basically, if you have a space and you measure out the distance from one point to the edge of your field, you will be able to create a scale drawing, and that's what we call our radial survey. So here on our next page, we've got an example of a radial survey, and this is just giving us information on what the size of the paddock is. But obviously, if we wanted to transfer that on an A4 piece of paper, we won't be able to draw 8 meters by 9 meters by 11 or 12. We won't even be able to have the compass bearing for that. So what we do instead is we shrink it to scale and draw a scale drawing of our aerial view of a plane. For instance, this is a paddock. Now, the reason this is helpful is because we can now start to use trigonometry to work out the area of different sides. We could also use trig to find out the length of these sides here. And that's using like the sine rule, the cos rule, and other things related to that. So what we're going to do is work out the area of ABC. Now the easiest way to do this is because you've got 3 triangles, you've got 2 of the sides and the included angle in between them, we're going to split them off into area 1, area 2, and area 3. So we're going to call this area 1, call this area 2, and area 3. Now how we work out the area for the first triangle is to just do half times AB sine C, which means half times 5 times 7 times sine 82. And that's going to give us an answer. Our next triangle is going to look like half times 5 times 4 times sine 136. And our last triangle is going to look like half times 4 times 7 times sine 142. Now, when we add all these up, you'll notice that I don't have to work out the solutions for all these. I can just type all of this in one go. So what I'm going to do is I'm going to do half times 5 times 7 times sine 82. And then I'm going to add half times 5 times 4 times sine 136. And then I'm going to add half times 4 times 7 times sine 142. And that total is my area. To one decimal place, I'm just going to go 32.9. Alright, meters squared. And so that's how we find the aerial survey for this example. Now, on to our next example. We want to find the angle sides of POQ. Now, an example of this radial survey is given to us. This tells us it's 72 degrees over here. This tells us it's 290. The easiest way to find this angle here is to do 360 minus 290. Alright, so we're going to just do that now. That gives us 70. So we know the total angle in there is 142 degrees. What we can also do is find POQ. Now, if we know that this is 72, and if we keep going and that's 145, then 145 minus 72 is 73 degrees, and that's what the size of POQ is. To find POR, that's what we've been doing. We're adding these two numbers together, and then we get 142. What we also need to do is calculate the length of PQ. Okay, that's this side over here. So what I can see is we probably need to use the sine rule. We probably need to use the cosine rule, because if we are missing this letter here and we have the included angle in between, the cosine rule is one quick, easy way of getting the answer. So the cosine rule is c squared equals a squared plus b squared minus 2ab cos c. So we've got a squared, we've got b squared, we've got 2 times a times b times cos c, and we're going to type all that in the calculator. And then square root this answer, giving us 5.537. Because our answer is to 2 decimal places, it's just 5.54 meters. All right, and that's how we work out one side. To work out the other side, PR, we have to do something similar. We've got 1, 2, and 3. So what we're going to do is the same formula. I'm just going to start substituting now. So we've got 4.7 squared plus 4.8 squared minus 2 times 4.7 times 4.8 times cos 142. We, again, because that equals to c squared, we need to square root that afterwards. So square root of 80 gives us 8.98 to 2 decimal places. So now we've got 8.98 over here, we've got 5.54 over there, and then to find the perimeter, we just need to add all the given sides. Alright, and you'll see that I didn't add 4.8 because this part is not part of our perimeter. And that gives us 23.72 to 3 significant figures, 23.7. Don't know why I wrote 4. Okay, so our last example of a radial survey is shown below. So radial survey of the land DEFG is shown below. So what's the angle of FOG? Alright, now girls, to find this angle in here, it's actually really easy, especially if we're given true bearings. It's always just the bearings minus from each other. So 260 minus 157 gives us 103, which is the angle in there. Alright. Now the area of triangle FOG, because we've got A, B, and the included angle, which is sine C, we can just do half times AB times sine C. So we're going to type that in our calculator, half times 30 times 45 equals 657.6997 to the nearest square meter is just 658 meters squared. Now, for the last question, which asks us to find the distance between F and G, we're just going to be using the cosine rule. So we've got c squared equals a squared plus b squared minus 2ab cos c. All right, a is 30, b is 45, minus 2 times 30 times 45 times cos 103 gives us 30 squared plus 45 squared minus 2 times 45 times 30 times cos 103. And then remember to square root that sign afterwards. So the distance is 59 meters to the nearest meter. Okay, so here are some extra multiple choice questions we've just put in at the end of the booklet. For this question here, you'll notice you don't need the sine rule or the cos rule because it's a right angled triangle. So the length of A is just going to be opposite over hypotenuse. A over 14 equals sine 63. Then what we do to solve it is just go 14 times sine 63 equals A. Which one of these says 14 sine 63? So the answer is B. The correct expression for x, this one, you would need the sine rule because it's not a right angle triangle. So first of all, we're missing this side angle here, 180 minus 39 minus 29, that's 112. So x over sine 112 equals 5 over sine 29. Move that over there. And then we get 5 times sine 112 over sine 29, which is our solution. Last but not least, how would sine theta be calculated? Sine theta over 5 the same as 8, or sine 64 over 8. But more importantly, we could work out this missing angle. Actually, no, we can't. Right, and the way we'd solve this is move the 5 over there. So sine theta equals 5 times sine 64 over 8, which is B as well. Okay, so remember which formula you use. You can follow this diagram here. You can also follow the other diagram that I've put online on the Google Classrooms for both classes. If it's a right angle triangle, you're thinking of using SOHCAHTOA or Pythagoras. If it's non-right angled triangle, you'll think about using the area of a triangle formula or the sine rule or the cosine rule.